We have seen earlier in kinematics the motion in one direction. Motion in one direction, for example, when the object is been thrown vertically up, the object is affected by the acceleration due to gravity. Where the object has been, its velocity will keep reducing until it reaches the maximum and it follows this trajectory. If the same object is been thrown horizontally, in that case, the acceleration horizontally is considered as zero. Let's say if there is no friction or something, it's a uniform motion, the object will be covering its equal distance in equal interval of a time. We have seen already that this is what the uniform motion. But what about if the object is thrown at an angle? So you can see in that the chest, the guy is throwing this object in this trajectory, then it is also going higher and it is also reaching farther. I mean, something. So if this guy threw this projectile with certain speed, making certain angle, then this is what the trajectory is been following. This trajectory in mathematics, we call it as the parabolic trajectories. We'll get into the details. So in order to explain this like projectile motion, let's look at here in this simulation. So if I throw a projectile, making an angle, it follows this trajectories. It follows this trajectory like this. Over here, this vertical velocity is reducing while horizontal velocity is remaining the constant. The reason being the vertical velocity is reducing because the gravity has been pulling it down and the horizontal velocity stays the constant. So in order to understand, like in order to find out the max height and time of flight and then range, we will always like split this vectors, this velocity vector into its vertical component and into the horizontal component. We'll see here in this. So here, when the projectile reaches its maximum height from the ground, that height is called as a maximum height. In question, they'll ask you to calculate the maximum height. Then also, what was the total trajectory time? So while the projectile was in the air, what was the total trajectory time? That is called as the time of flight. Time of flight. Then how far the projectile landed from the launch point? That is horizontal distance, which is also called as the horizontal range. So how to find out that? We will see. So I told you when the velocity is, let's say in this example, if the projectile is launched with 40 meters per second at an angle of 30 degrees with the horizontal, then we will be able to calculate using this trigonometry. It's horizontal component of the velocity, which I'm going to call it as ux. That is going to be u cos 30 in this example. And this will be the vertical component, which I'm going to call it as u1, which is the 40 sine 30. So you get the initial vertical velocity and initial horizontal velocity. So just to represent over here, I'll draw the initial vertical velocity to be uy and initial horizontal velocity will be ux. And this keeps on changing. The vertical one keeps on decreasing. You keep reducing, but the horizontal remains constant. Keep decreasing, horizontal remain constant. At the max height, the vertical velocity becomes eventually zero. And then it starts increasing but in opposite direction. So vertical start increasing but opposite direction, and horizontal remain constant. So in order to solve for the max height and range, let's get the classification of its vertical motion and horizontal motion respectively. So we knew that in vertical motion is along the y-axis, since it is accelerated motion. I'm going to use the Subat or kinematics equation. But here I have just tweaked this equation saying that y, indicating that's the velocity in y direction. So I'm going to read like this. Vy is equal to uy minus ay into t, stands for final vertical velocity, initial vertical velocity, acceleration in y direction, and then time runs simultaneously for both the motion. Similarly, this second equation tells me that the Sy is the total vertical displacement, Uy is the initial vertical velocity, Ay is the acceleration in y direction, and then Ty is the time. So I'm going to use this kinematics equations, and using this kinematics equation, I'll be able to calculate max height, that's vertical motion, and then time of flight as well. We'll see. If I do the same thing for the horizontal, we write like this. If I just show you, if I write Vx is equal to Ux plus Ax into t. So over here, the acceleration in x direction is considered as zero because the object is not accelerating horizontally. I've written it over here. And using the second equation, you get Sx, which is equal to Uxt, so 1 half ax t squared. Again, the acceleration in x direction is zero. So this equation tells me that the displacement in x direction is horizontal velocity into the time, and that is what we calculate the range. So using that horizontal velocity, you will be able to calculate the range of that projectile. So I'm gonna follow this. Let's see this calculation thing. In order to find the maximum height of a projectile, I will use this kinematics equation. The Vy square is equal to Uy square plus 2ay into Sy. And the trajectory would look like this. So I would definitely know its initial vertical velocity using that component thing. And at max height, the Vy will be zero. And I'm looking for this height, which I'm going to call it as the maximum height, h, which is same as s with the suffix 1. So what are the knowns and unknowns? So I'll see this known is u1, acceleration in y direction, and then vy will be zero at this point. So if I just write down in form of equation, then this turns out to be 0, which is equal to u sine theta, the whole square, plus 2 into g into the s bar, which is the max height. And you can make this equation, the height will be equal to u square sine square theta upon 2g. That's a max height. Okay. So in order to find the time of flight, the trajectory goes like this. And then again, the time of flight is considered or calculated using vertical motion. Using vertical motion. So what are the knowns over here? Again, we knew the initial velocity. I'm going to keep it as u sine theta only. And then if the trajectory is symmetric, like in this, so your start height and then end height is on the same level in this case, then can I say its vertical displacement gonna be zero? Its vertical displacement gonna be zero. And we already knew its initial velocity is u sine theta. Acceleration in y direction is negative 9.81, or same as the negative gravity. And I'm looking for this t, the node. And so I can use Sy, which is equal to uyt plus 1 half acceleration into y direction times t square. So check, in this case, the displacement is zero. The vertical displacement is zero because the object started from this point, ended over here, so its vertical displacement will be zero. But this is not always gonna be true. What about if the object is launched from certain height? Let's say in this case, the height from which the object has been launched is 40 meter, for example. Then the trajectory will follow like this. And now the vertical displacement has to be, it started over here, ended over here. Its vertical displacement will be this. Sy is negative 40 meter. So I'll place this Sy to the negative 40 meter over here. to get the time of flight. So I can use this same equation even when the projectile is symmetric. So when I say symmetric, it takes about the same amount of time to go up and same amount of time to come down. But in case of non-symmetric, it doesn't take the same amount of time to go up and come down. So that's why I'm going to use this equation to find the time of flight. And in order to find the range of this projectile, the range is this horizontal distance. If this is the range, so I use this horizontal velocity into the time of flight. So we know the horizontal velocity ux, which was u cos theta, if the theta was made the angle with the horizontal, and then t will be the time of flight. So range is calculated as horizontal velocity into the time of flight, the total time. And I'll be able to find the range of this equation as well. So what will be the effect of the trajectory, or what will be the effect of air resistance on the trajectory? So you will see if I launch this projectile without air resistance, this is what the trajectory follows. It is you will be able to calculate its max height using the simulation, and then time of flight and then range as well till here. But you see the same thing with the air resistance. If the effect of air resistance, its max height will be reduced and its range will be also reduced. And then graph will be more symmetric. So you can see the max height has been reduced, the range has been reduced. And the